Okay, we're continuing on helping you learn some useful mathematics here. You've learned a little bit about doing percent increases and decreases, and I want you to notice a pattern that makes this go even nicer. I mean, I could say, honestly, here's a shortcut, but I don't like to think of math as shortcuts. I like to think of it as noticing a pattern and then using that pattern to make things work more efficiently. That's just the way people work. So let's do it that way. So here we go. I want to look at this question here. What is the result when 40 is increased by 20%? And maybe it's $40 jacket they've marked the price up $20 so they can, or 20% so they can make a profit. What you would do is this. You'd calculate 20% of 40, okay, because this price has been, this $40 has been increased by 20%, and then you would make sure you added that on to 40. Okay, so what I've got here is 40 plus 20% of 40. Okay, before I show you the pattern here, I want you to do another one here. With this one, what's the result when 84 is increased by 12%? Well, you would first calculate 12% of 84, and then you'd add that on to the original 84. Okay, I'll show you in just a bit why I'm putting the 84 first, and then the plus 12% of 84. Let's look at another one just once more. So to find the result when 150 is increased by 30%, you'd calculate 30% of 150, and then you'd make sure that that was added on to 150. Okay, so notice that we're doing the same thing every time. We're starting with the original amount, and we're adding on the percent of that amount. Okay, same thing here. Same thing there. Well, on this one, I want you to see something that's kind of cool. It's using what you've done before. It's called the distributive property, and I'm going to use the distributive property backwards. Okay, what the heck do you mean by that? Well, take a look at this. I'm going to take this 40 and I'm going to write it out in front right here of a set of parentheses, and then I'm going to put a 1 plus 0.20 right there. Okay, and now I want you to think about this statement going from here to there. Back when we did the distributive property, we took the number outside and we multiplied it by each thing inside. So we went multiply there, then multiply there. Well, I want you to notice that when you do this, when you do the distributive property, you get back to this. Okay, 40 plus 0.20 times 40, because you had 40 times 1, that's your 40, and 40 times 0.20. So here's 40 times 0.20. Okay, so this thing can be written this way. Let's look over here. This thing could be written this way with the 84 out front and then a 1 plus 0.12 in parentheses. Okay, and the same thing with the next one. This one could be written with the 150 out front and then 1 plus 0.30 in the parentheses. Why are you doing that, Mr. Academy? You're just kind of messing around with things. Well, check this out. Would you please, in your head, add those together? What do you get? 1.20. Okay? So I still have a 40 out front, and here's what I want you to notice. You've taken this complicated statement here, and in 2 steps, undoing the distributive property and then combining these two into one number, you've made it into a simple multiplication. 40 times 1.20 will do the same thing as all of this, but it's in 1 step, okay, not 2. Okay? So when I look down at this next one, right here, I can combine this into 1.12, okay, and now it's a simpler multiplication to do. 84 plus 1.12 instead of 84 plus 0.12 times 84. It just makes it go faster. So what would you do to get this one? You'd write it as 150 plus 1.30. Okay, so what I've done is essentially I've taken the starting number right here. I wrote this number as a decimal and then put a 1 in front of it. Okay, let me say it again. I took this number right here, 150, and I took this number as a decimal and put a 1 in front of it, and then I just multiply those. So here's how I'm going to use this thing. Right here, I could write this, 60 plus 0.015 times 60. Notice I moved the decimal place 2 spaces, okay, to make it into a percent. Okay, I could write this, but you know, it'd be a lot faster to just do this. 60 times 1.015, and just multiply those, and I've got my answer. Okay, so I could do any of these problems here. Let's just make up a new one down below here. What is 85 increased by 6%? Well, I'll just do 85 times this number is a decimal with a 1 in front of it. Okay, do that multiplication and you're done. Okay, so it speeds up trying to do a percent increase. Okay, now I'm going to try to blow your mind a little bit. Okay, what happens if it's a decrease? Okay, so I've got the same problems written right here. Okay, except I'm going to change this to a decrease. Okay, well, before, when it was an increase, didn't I do this? I took a 40 and I had 0.20 times 40, okay, and I added them together. Okay, and then I showed you the shortcut where you could just write 40 out front and then 1.2 inside there. Okay, well, with a decrease right here, the only difference is this. That plus is going to become a minus. I would take 40 and subtract 20%. Okay, let's rewrite this thing this way. Okay, we undid the distributive property. Now, what is this when you combine them? Well, it's not 1.2 anymore. It's 0.80. And you'd still have a 40 out front. So you could just go 40 times 0.80. What I want you to notice is this. The only thing between an increase and a decrease is instead of adding on to 1, you subtract it from 1. Let me say that again. Instead of adding on to 1 like we did before, we subtracted. Let's take a look at one of these things. Okay, over here, I basically added the 0.015 onto a 1. So instead of being 0.05, it's 1.05. Okay, up on this one, instead of adding 30%, the 0.3 to 1, if it was a decrease, I would subtract it. So let's look at a new problem down here. Okay, what is the result when 84 is decreased by 12%? Well, I could write it out this way. 84 minus 0.12 or 0.12 times 84. Okay, and then I could undo the distributive property this way. Okay, or I could make it even faster by writing 84 times what is 1 minus 0.12, 0.88. Okay, so what I figured out is a faster way to calculate percent increases and decreases. Let's look at this one here. Instead of asking what the result is when it's increased by 30%, let's do a decrease. And I'm going to save some time by doing this. I'm going to say 150, and then inside the parentheses here, instead of adding the 0.3 onto 1, I'm going to subtract the 0.3 from 1 and get 0.70. By the way, here's a nice way to think about that. If you took something and you decreased it by 30%, what percent is left? 70%. Okay. If you decreased something by 12%, what percent of it's left? 88%. Okay. If you decreased by something by 20%, what percent's left? 80%. Okay. So it makes it a real nice little way to figure this thing out here. Let's change this to a decrease. I'm going to start with 60, and then in the parentheses, instead of adding the 0.015 onto 1, I'm going to subtract it. So I'm going to grab a calculator off screen here and figure out 1 minus 0.015, and I get 0.985. So I'll just put a 0.985 right in there, do the multiplication, and I've got my answer. So we've now found a faster way to do percent increases and decreases. So let's just make one up. Let's do 75 decreased by 15%. Okay, so I'm going to take the 75. In the parentheses, will I add the 0.15 onto 1 or subtract it? Well, because it's a decrease, I'm going to subtract it. So 1 minus 0.15 is 0.85. Or you could think of it this way. 100% minus 15% is 85%, and then change it to a decimal. Okay. So how about this one? 92 increased by 10%. Well, I'm going to take 92. In the parentheses, will I add the 0.10 onto 1 or subtract it from 1? Well, it is an increase, so we're going to add it onto 1. So 1.10. Do the multiplication, and you've got your answer. Okay, so I'm going to have you practice a few of those using Delta Math, and we'll see how it goes.